So as Paul said, we have been trying to start some activities in the area of data and cities. I want to tell you a little bit about our motivation behind doing that, and then give you some examples of some of the activities, initiatives, and projects that we're doing. It's a relatively new activity that's just been in the last year or so, and so I'll tell a little bit about why we decided to do this here in Chicago and what some of the opportunities were that drove us in this direction. So the center was started last fall, and one of the things we tried to do was to begin to just pull in leaders who had thought about urbanization and using data in cities. So we were able to get Argonne from the Obama campaign. He was the chief scientist, to come in and be our chief data scientist, and then more recently the former CIO for the city of Chicago, who has been a leader in cities opening up data and publishing data, and then using that data along with internal non-published data to run the city better. A lot of the context to what we're doing is maybe not unique to Chicago, but certainly unique to Chicago in the last few years with the new administration, with Rahm Emanuel coming in. We saw a real change in the city, in the leadership, not just the mayor, but the layers below the mayor, moved from let's just keep the city working, everything's okay, we'll just keep it going, to a mindset of let's change the way the city works, because the city doesn't work for people very well oftentimes. And so a lot of the push toward open data and into things we're doing, you can think of as trying to help cities go from reactive policy and intervention to proactive policy and intervention. And so there you get into the need for predictive analytics and data mining and things like that. Just stepping back, most of you probably know that we passed a milestone a couple years ago. Now 50%, more than 50% of the people on the planet live in cities. You could argue about what I mean by cities, a million people or more, or what have you, but the trend is pretty clear toward urbanization, and that has some consequences for us thinking of from a scientific point of view, and particularly coming from a Department of Energy laboratory. To just put some concrete numbers by example, looking at China over the next few decades, they're going to see enough growth in urbanization, they'll see 400 million new city dwellers, or they have to accommodate them, and that means they've got to build the equivalent of 10 New York cities, and if you spread all that floor space out, it would cover the country of Switzerland. Now with those buildings come roads and utility networks and schools and economies and things like that. And that's just an example of the developing world. So most of us live in the developed world, in cities like Chicago or San Francisco or New York or London or Barcelona, and our cities aren't growing the way that cities are growing elsewhere. And so if we just live in those cities, and most of our travel is also to other developed world cities, it might sort of sneak up on us how cities are changing because we don't see it. So you look at Chicago here, this is some really interesting, if you can read this, and some really interesting research that a group did, some folks from Yale and University of New Hampshire, repurposing data from some NASA satellites. They repurposed the nighttime light data to figure out density, and the microwave backscatter to figure out the height of buildings in the cities. So I'm not a microwave backscatter guy, but I take their word for it. And what they did is they divided cities like this into a grid of 11 by 11, and for each of those grids, the start of the vector is 1999 and the end of the vector is 2009. And what you can see is Chicago is a typical example where, yeah, it got a little bit taller and maybe a little bit wider, but cities in India are getting just wider, and cities in China are taking off in terms of the density inside the city, represented by tall buildings, and also their spread. Another satellite view, this is the Pearl River Delta in 1980 Landsat. So red is vegetation, and here it is in 2005. You can see lots less red and much more concrete. China's going to spend in this area here, this is about 40 million people live here. China's going to spend about $300 billion over the next 5 or 6 years to create a single city of 40 million people. how they do that, how they plan their transportation, how they plan their energy delivery, will have a significant impact not just on the planet, as you can see here, which means on the climate and on water, but also on global energy demand. So even though this is happening on literally the other side of the world, and it's not happening in Chicago or New York, it's still relevant to us. So when we looked at that, we said, gee, it seems that when cities grow, there are at least 3 spheres of impact that we could imagine trying to understand. One is the impact on the environment, the other is on infrastructure, and the third is on people. And so we've assembled a team from the University of Chicago and Argonne, and Skidmore, Owings & Merrill they're an architecture firm. They build world's tallest buildings. So if you can name any of the world's tallest buildings in the last 20 or 30 years, they probably designed it. But they also have a city design practice. And then the architecture department at the School of the Art Institute at Chicago. So we looked at those 3 types of impact and we said, well, do we have tools that we can use or approaches that we could use to try to understand as cities grow rapidly or change rapidly what that means to these different spheres. So I just put this up to show the mix of people that we have. And the other thing that's unique about this is that we have, if you look toward the right is the U of Chicago people, where we tend to be strong in the social sciences and policy and economics. And on the left-hand side, you see the hard sciences at a place like Argonne. Most of the initiatives out there, and there are quite a few, that are trying to understand urbanization in cities tend either to focus on the right-hand side of social, economic, and policy, or on the left-hand side of the city as a big deterministic system of systems. And what we're trying to do is bring those 2 views together. Traditionally, the way that social scientists have studied cities is using stale data that's, in some cases, not really even data at all. And by that I mean some of this up here, these nice maps are based on data, the census over here on the left, obviously, some of the social service data in the upper half, but also interviews. So orange in this bottom right, these are all Chicago in case you didn't recognize the shape. The orange are high gang activity, but that's not data, it's anecdotal information. It's good information, and it's just based on talking to police and people that live in the neighborhoods. One of the changes that's happened in many cities, including Chicago, is that lots of data is now becoming available to social scientists that has never been available before. And this is a screenshot of the Chicago data portal. Lots of other cities have this as well. There are about 750 data sets in there. You can certainly use the clunky portal interface, and some people do, but you can also write code that extracts data from this, about less than a dozen lines of R code, and you can have your own view of a particular data set. So with this kind of data being published, we began to work with the city of Chicago to understand how we might make this data more readily available to people that want to study it. In particular, the consequence of sparse amounts of data is that a social scientist will look at one slice of the city. Let's say they want to look at 911 calls or crimes or something like that. And if they can get that data, it's enough for them to just work on that, but they don't have the ability to pull in data from lots of other sources and ask if there is a correlation between, say, real estate transactions and tax receipts and crime. We have other data, some of which is public, some of which is not. There's also some fun data. This is a snowstorm back in January of 2012, and the red dots are the snow plows moving around, and they drop a blue dot when they clear a street, so you can kind of see the streets emerging from this animation over about a 2-day period. But the city of Chicago, like other cities, I suppose, are tracking lots of their assets with GPS, and this kind of information is available during and after these kind of events. And so there are questions that you can ask about the way a city is working that you wouldn't have been able to ask a few years ago. A simple question like, how far did the snowplows drive, and how much fuel did they use? Maybe you can get the fuel, but you wouldn't necessarily get the mileage. You could ask a question that is the algorithm that they're using to clear the streets the best algorithm to use? It's not just, it's a complex algorithm, not super complex, not like you're talking about during the day. Here it's not an exascale algorithm, but it's not a simple one. So we began to work with the city of Chicago about a year and a half ago to understand what are the challenges that cities like Chicago have, and then see if we can draw a line between some of their challenges and some of the capabilities that we have at Argonne, University of Chicago, and places like that. And one that we focused on was creating this neighborhood health index. So this is a list that comes from the chief data officer from the city of Chicago. The neighborhood health index it came from the mayor saying, I would like to know before a neighborhood goes under economically or has crime that goes out of control, I'd like to know ahead of time when something is headed in the wrong direction so I can intervene. Well, that's a pretty complicated thing to try to do. It means, first of all, deciding what is a neighborhood and bounding those areas that you want to look at, but it also means looking across lots of different data about that neighborhood over time and trying to figure out what's relevant, what's causal, what's just coincidence. And so this is a project that we've begun to do with a team of folks from the U of Chicago and Argonne, with the purpose of trying to at least get some level of index of a neighborhood from a social economic point of view. And I'll come back to an example of that in a few minutes. The other thing the city is doing that is pretty unique, this is a project that there was something called the Bloomberg Challenge that there were 300 cities that were competing for a $5 million prize to do something innovative in their city that could have impact in the city, was feasible and reasonable to pull off, and could be deployed in other cities as well. So what Chicago did, and we came in as one of the top 5, so we got $1 million, we didn't get the $5 million, is for the NATO meeting that happened a little over a year ago here, they created a situational awareness system where they could look at all of these and other things here in this list all at one time and map them on a map. What they've done in the police department, but not for the whole city yet, is some level of predictive analytics so that they could, for public safety, there's a simulation that runs roughly every 8 hours, and a target package or a piece of information goes out to each precinct that says, here's a map of your precinct, and it's coded to tell you where you're higher than normal, you have a higher than normal likelihood of a violent crime happening. And that's a set of predictive analytics that's based on, how many people know what a 311 call is? Or so, you know what 911 is? You call 911 if a murderer gets out of prison. You call 311 if a llama escapes from the zoo. It's a non-emergency service request. So you call 311 if a street light is out, or your garbage can is missing, or there's a pothole or something like that. But those are measures of neighborhood disorder, if you will, and they have they are related to crime and other things. So we're working on this system here with the city, and here's where our capabilities from the high performance computing meet the needs of the city. And that is the data that's coming in at the moment it's not exascale data. It's not even petabytes of data. It's more in the hundreds of gigabytes range, but it accumulates over time. One of the large data sources that they're doing nothing with right now is video. There are a couple thousand cameras, and they don't have a way to pull those into this sort of situational awareness system. GPS data is about 7 million records a day, because every vehicle, and asset by asset, I mean like a city-owned cell phone, reports its speed, heading, and location every 20 or 30 seconds. So we're working with the city to design this overall system here, and in particular our role is in the scalable data management. So that's an example of a project where we've found some utility for our high performance computing in cities. Another area of opportunity that is fairly unique to Chicago is a project called the Chicago Lakeside Development. You see 3 pictures of it here, one conceptual, obviously 2030. In 1930, this peninsula was the U.S. steel plant and employed about 30,000 people. To the left of it here in 2013, you find what looks a lot like Detroit. Very high unemployment, very low graduation rates in school, high crime, poor health. And this is the part of the city that was the booming manufacturing part of the city 60 or 70 years ago. There is now a plan that is being executed to turn this area into a second downtown. We've been working with the architects, Skidmore, Owings & Merrill, who I mentioned before, and the developers, U.S. Steel and McCaffrey Interests, to bring scientific computation and simulation to this issue or this capability of designing a large-scale development. To put the size in perspective, Chicago Lakeside have laid it over two cities, Beijing, if you're familiar with Beijing, the central business district, and then I didn't lay it over. So I didn't lay it over Chicago. So the yellow is Lakeside there. It is about the size of downtown Chicago, the loop, 600 acres. What I've highlighted in red here is a typical size of development of around 20 acres, which is an area called Lakeside or Lakeshore East in Chicago. Urban designers and architects are fairly comfortable at the single building level or at up to 10 or 20 acres, but beyond that, it is pure guesswork. And the problem with guesswork, it's a problem in general, but for something like Lakeside, is that it is on the shore of 20% of the world's fresh water supply, and it has a sustainability plan that, unlike the rest of Chicago, would, for example, put all of the stormwater runoff into the lake. Now, that's a good thing after the first inch of rain washes away all the stuff on the streets. It's a really bad thing if you don't clean that. There are decisions that are having to be made now about infrastructure on this project that are, as I said, sort of guesswork. And what we're trying to do is we're saying, oh, you know, if you make changes in the zoning, you change the mix of residential to retail or commercial, that's going to have some impact on your transportation needs or your energy needs or water. And then if you make changes to the physical layout, the geometry of the site, maybe add green roofs or maybe add parks or make the buildings further apart, that also has impact on things like the civil engineering design that you have for stormwater management. And what we're trying to do with this project, which just began, is to go from this scenario here where an architect comes up with the geometry of the site and a conceptual diagram like I showed you, and then independent consulting teams go out and say, well, you're going to need this much energy supply, this is your water and sewage plan, here's your stormwater management, here's transportation, et cetera. And those blue arrows, those companies don't typically talk to each other. And then you hope at the end that you have something that is actually does what you think it will do. And that works with a building and maybe for 10 acres, but nobody believes it will work for 600 acres. So we have a project it's a proof of concept. It says, imagine that we could take an existing design tool like from Esri, something called City Engine, that lets you lay out a city and allows you to put attributes on buildings to your heart's content. Add attributes that aren't there. It's a procedural based program that every building is described in an XML file. And what we want to do is take those attributes for those buildings in that area and feed them into existing computational models that exist at places like NREL and most DOE laboratories, in order to say to have either the city or an urban designer sit down and say, okay, here's my plan. What's my energy use as a function of seasons or even daily? As it turns out that transportation models tell you when people are traveling, which also tells you when they're home or not home. So you might be able to even get to the sort of daily cycle of energy use. Possibly answer a question like, okay, here's my civil engineering plan for stormwater management, but what if I zone the area so that half of all roof surface has to be green, and now I've got all these water buffers, so can I save money on the plan for stormwater treatment by changing zoning like that? As I said, it's a proof of concept 6-month project that we think has good promise and certainly meets a huge demand in the industry. That project is in fact 50% funded by the developers for Lakeside. and it'll all be open source, so we're not just working for them. I mentioned that we hired Raed. Raed was about 2 weeks before he started working for us. He was at some kind of a meeting with Google's chairman, Eric Schmidt, and Eric said, "What are you doing now that the campaign's over?" And Raed described some of our thinking in terms of creating expertise in data sciences. And so Eric said, okay, he got his checkbook out. He said, "I want you to go for it this year." So we got funded for the summer, and we brought in 36 students to work in teams on projects for a variety of customers, and I'll show you the list of projects. We got 550 applicants in about a 3-week period of time. So lesson one, there was a huge demand for learning this, or maybe just for learning it from Raed, I don't know. And we chose them from 22 different universities. The demographics of the group, about half are PhD, postdoc, professional people, about a quarter are master's students, and about a quarter are undergraduates. About a third of them are women, 2/3 of them are men, and then these are the disciplines on the right. So we didn't engineer any of the demographics with the exception of two things. One, we tried for this mix of disciplines, math, statistics, computer science, and then social sciences. And we had to throttle some universities that already had such a strong program that if we had just gone by quality of student, we would have ended up with, lots of students from places like Carnegie Mellon University that have existing programs. So other than that, this was an unplanned set of demographics. These are the different groups. There are 12 official projects and a few unofficial projects. I want to just close with 2 examples. We took over the north half of the 23rd floor of a office tower downtown, so looking down over the river. It's a big open space, about 4 times the size of this space, where all the students are working in teams of 3 or 4 on one of these projects. And they're all mentored by a full-time professional who was able to take 12 weeks and do this for the summer. We pay the mentors as well as paying the students. And as I said, it's a 12-week program. We are in week 10 right now, so I've seen some really nice results. This is, as you might have guessed, an abandoned building. Abandoned buildings have huge economic and public safety impact on neighborhoods. And so a number of municipalities around the country have started things called land banks. So there's a Cook County land bank. Cook County is the county that Chicago sits in. Their role is to take abandoned properties and either refurbish them or more often demolish them. As it turns out that leaving a property abandoned drives the real estate prices down in the neighborhood, it drives crime up, it drives businesses away. And so the trick is to figure out, with a limited budget of money, where do you buy abandoned properties in a given city so that you'll have the greatest impact. I was talking to we've worked with a number of the suburb mayors. Here I was talking to the mayor of Oak Park just on the way here. He was telling me about a project I didn't know about. He said that in Flint, Michigan, the land bank there invested about $3.5 million in buying up properties in a particular area, and they calculated the economic gain to be over $100 million from that small investment. So besides making the neighborhood nicer, it has a significant financial impact. Chicago is one of the hardest hit by this housing problem. So here you can see, again, the city of Chicago color-coded by the percentage of homes that are foreclosed and abandoned. And you can see so the black means there's not enough data there or not enough places. But you can see that there are a fair number of areas in Chicago where more than 30% of the properties are abandoned. So the work the students are doing with the Cook County Land Bank is really directly related to that neighborhood health index that I mentioned. Because the Cook County Land Bank wants to know, where are the neighborhoods that are on the edge of decline, where we can invest a little bit and bring them back from the brink. Because the neighborhoods that are already over the cliff are easy to find and very hard to fix, and very expensive if you could fix them. So that's the first project. And the second is with, that I want to talk about is with the Chicago Transit Authority. So here's a map. The students built this tool. Here's a map showing the distance in time using public transportation and walking, obviously, to the stops or whatever, from all these locations in the city to the one point that's there. So this is a tool, the interactive tool. You drop a point on the map and it redraws the color by how long it takes you to get there. Perhaps not surprisingly, these gray areas, that is not at the heart of the loop, that marker, but it's where you might find some jobs. The gray areas are underserved by public transportation. They also tend to be the same areas that I mentioned before, with high unemployment, high crime, poor health and education performance. So this is a possibility or an opportunity to influence the city in a way. I don't have a picture of this, but we did a similar study at the university a couple years ago looking at just the south side and the number of minutes that it would take to walk to a grocery store with more than 2,500 square feet. Because at that threshold, that grocery store is going to have fresh produce and other healthy food. And below that, they're going to have burritos and processed cheese and stuff like that. And so we found what became known as food deserts, large places in the city where you couldn't get, if you walked, if you didn't own a car, you couldn't get healthy food. So what we're seeing here, we said, well, these are public transportation deserts. And the city has an opportunity here to do something similar to what they did with the food desert. With food deserts, the mayor met with the CEO of CVS and Walgreens, the two drugstore chains, which are all over the city, including in those food deserts, and said, let's work out a deal where you carry fresh food. And they started carrying fresh food, and we'll see in a few years if that makes a difference. Here, the CTA could reroute or reschedule buses and hit some of these areas. It's hard to reroute trains. But it's an example of doing just some simple data analytics that the city has never had the capability of doing before, and being able to affect public policy that has really a big impact on the city. So I'll close by showing you a slide that our Argonne's director used in a recent strategy session with the part of the DOE, the energy efficiency and renewable energy. This is the part of DOE that has lots of programs in the components of cities, windows, water heaters, buildings, but nowhere in DOE is there a program that looks at cities as entities. And so we were trying to make the case here that that's an oversight, a huge oversight, we think, in the federal research program. So we're hoping that over the next year or so, as we continue to work, that we will be able to persuade some of the funding agencies to focus some of their attention on some of these emerging computation and data challenges. So with that, I'll take questions or give you your time back. Thank you.